Okay, might as well start, eh? Okay. Hi, I'm Colin, known as Foskers on all the internet things. I am talking about how to write. It's kind of two things. It's how to write fast Scala and how to not write slow Scala. Those aren't exactly the same thing. The talk is mostly the former. The past 4 years of my professional life have been in Scala. 2 years of that was working on an open source big data, like high performance numerical processing library. If you're interested in that, I can tell you it's in the GIS space. It uses Spark, where there were a lot of considerations that we had to make. That was originally written or rather, it was started in 2012, and so it's like a relatively old project, still going. There were some solutions, there were some problems for which FP was the only answer. Like there was a particular bug that came up, we investigated it. Well, when I did said investigation, the answer was trivially functor. There was just a particular thing that had to do with threading access through a particular type variable down these weird nested structures. Like, oh, this is just functor. After we did a bunch of ad hoc experimentation, me and a colleague, we found out, oh, this is functor. Wait a minute, we're not depending on Scala ZR-cats. Because at the time at least, the team lead was mostly opposed to imposing that API burden on the user, with the implicit assumption that FP is hard and you need to be a wizard to do any of it, and also the implicit claim that by including any use of those libraries in your machinery, that necessarily means that the user will become conscious of it, which is not necessarily true. That doesn't, your internal mechanisms don't have to percolate up to the API. So we had to make a decision about which one to use because we had a custom functor. I had written a shitty, pardon my language, video people, a custom functor that was just in our code, and we were kind of looking at it going really, do we need this? Why can't we just be using the community functors that we're used to, that are available in Scala Z and Cats? So I did a project that compared the two. I came to Scala from Haskell, so I don't particularly, so in that work and also in this talk, I don't have particular religious views surrounding Scala. I just want to be honest about what I've found. So I compared the two. I didn't really care about their histories. I just wanted to know which one was good. People had opinions that didn't seem to be, founded by anything. It's oh, this one is good for these reasons, or this one's good for that, or that's bad because blah. It's well, okay, what data do we have? I hadn't seen anyone who had done a comparison, so I did one. And that is this. The next 55 minutes are going to be me basically summarizing the contents of these two GitHub repositories. So, because humans like to talk to humans, so it's good if, text, and, text has certain barriers. So, my goal being that the information that's in there, while, clear and you can read it and digest it, the idea being that hopefully you can take this back to your own projects, to your own work, and help clean things up a little bit. While I was doing this comparison, I was doing a lot of benchmarking, so I found out about the Scala, I suppose it's an SPT plugin. It's called SPT JMH. It's the thing that I recommend. It's the thing that I recommend for benchmarking Scala code. Thank you. SPT JMH is the thing I recommend for benchmarking Scala code because its results are fairly consistent. It will fork a JVM for every benchmark you're doing, so you don't have to, and it will do proper warm-up calls, so you don't have to worry about, oh, was that on a cold or warm JVM, blah, blah, blah. While I was doing that, I got curious about certain data structures. So at the same time, I started benchmarking a lot of the standard containers, the collections that we use in code, and as well as like a lot of the paradigms that we use. Like if you want to be like mapping and filtering over things, or like pattern matching, deconstructing containers to find out certain things. It's like, okay, what's the cost of all of that? We're told that we should be using all these things. Are they actually good? So I wanted to find out, because I hadn't really seen anything on the internet, both for comparing those and for just general performance, other than the collection sort of performance chart, which gives like O of n performance characteristics for the containers. It's like, okay, those are nice, but you know, relatively speaking, how do they perform relative to each other? So I did that, and I found out some interesting things. Condensing those is the talk that we're going to have today. So the three main sections are concurrency, numerics, and collections. This isn't in order. I can do these in any order that you want. I could skip sections if they're not interesting. Numerics is probably the most skippable one. This is probably the most useful. Concurrency is mostly me ranting. So if you would, if there's like a vote, or like what are people interested in? Collections? I can start with collections? Okay, great. What's a list in Scala? That's what I was going for, yeah. It's a singly linked list that we don't need to really worry about the implementation. It does not have good random access because it is a singly linked list. But let me tell you, the first result is that list is almost the fastest thing in Scala. So, particularly tail recursion over lists that destructures, like if you're doing matching and you're desugaring and you've got something like this, and you got some whatever there, and maybe you're doing like nil here, say, and this is in a pattern match branch. This is one of the fastest things that you can do in Scala. Doing this is faster than fold left over a list, and it's also faster than maybe not always array, but we'll get to that. Point is, I'm trying to motivate that. List is quite fast. You can destructure its contents very fast. Do you want to know why? Okay. This is not an operator. It is a class name. It's a little trick. When you destructure this, you're actually pattern matching on the name of a class. The bytecode does this with some pointer tricks. So when you actually do this case, it's able to do this very quickly, like near instantaneous, because it basically just has to check kind of like a basic reference identity, like, oh, there is actually, if you go into the Scala standard library right now, it is called class ... and it extends a bunch of stuff. And this is that constructor. It's not actually a function, or a method, pardon me. Which is one of the things that makes list really fast. It's why you can iterate through it very quickly. Nil as well, because nil is like is it a case object? Case object. Yeah, right. So there's only ever going to be one of them. So it can compare to that really quickly as well. Compared to this, let's. I'm going to move this away for a moment. So if I'm just writing code, no, we're not in a pattern match situation right here. We're appending to lists. So what does that do?
Produces a new list with 1, 1, 2, 3.
Yes.
Shows the existing list.
Most likely.
What do you mean?
I think so. I'm going to trust your. I'm assuming that it does.
So yeah,
That is shared.
Yeah, it preserves the.
Like point is it doesn't reallocate the tail.
yeah.
Yeah. That's an important detail. What does colon goes on the side of the container? What does this do?
Oh, I have no idea.
Inspector, who knows?
I do. What does that do?
I'm guessing it reallocated the whole new vector.
It does. It reallocates the whole new vector. So one of the things that I'll get to when talking about vector is that,
Wait, the entire vector?
yes. What does this do?
You have no idea.
No, I do. Or, well, pardon me, yes, I guess it
It
depends on what this was. If this was passed in, like for,
It depends what your seek is.
yeah. Okay, yeah, the real answer is it depends on what your seek is, and I'll get to that. This is another teaser for when I get to seek about why to avoid it. If you're just inlined like this will most likely become a list. This is not the same as that. This, even if this is a list, this is twice as slow as that. Yes, I'm not lying to you. This, appending to a seek like this, so if you're building up a seek, this is twice as slow as that.
Wait, is that append or prepend?
That's prepend.
You said even if it's a list,
Yes.
that's something different than that.
Yes, and it's because of indirection and the way that all of the collections are implemented. So the collections are this giant graph of traits that kind of split up the individual characteristics of like everything that's possible on a collection. So you have like a traversable, then you have like a traversable once, then you have like a gen traversable once. So you can imagine that sort of everything that you can imagine doing to a container has a trait. For most intents and purposes, noobs look at that and they go, gah, including myself, I did that. I basically don't pretend to understand the entire thing. What most people get an understanding of is this, that, oh, seek basically gives me everything that I need. But seek can be tricky, and we'll get to that. So this is motivating some of the... and you can actually see it if you go to this near the bottom. I have some examples of both consing onto the head of things, and how fast it is to desugar based on this. Let's talk. Yeah.
So you're saying the seek one is the slowest of all three?
No, vector is the slowest because it reallocates the whole vector. Now let's talk about pattern matching. Crap. I pulled it up again. Rest. This will be A, and that will be A, and this will be rest, rest. Where this is a vector, and this is a seek, and this is an array. We'll pretend that that's there again.
These for array?
Yes, there is. It's hard coded. It's array doesn't. I think array does not extend seek, but it still has that. Pardon me.
Array gets, there's a way we slap an extension method class on.
Gotcha.
Yeah, but let me, for the array case, does it allocate an entire new array for the rest?
We'll get to that. So we're in a matching statement. We're in a matching block again. We already went over this. This is really cheap. What does this do?
No idea.
It calls unapply,
Yeah, yes.
which is a call that it didn't have to make.
You can do that in a pattern.
Yes.
That's what a pattern is a call to unapply.
No, I didn't know you could use plus colon in a pattern.
Yes, you can. It's pure evil. I know that because I used to write this code a lot. I used to do this a lot until I found out it was pure evil.
You can, because you can make an object out of plus or other tricks like that.
Why
The
then?
same trick they did with the double column. You can do with plus column, right?
I'm not sure. What's the claim?
That it calls an apply because plus columns an object or it's probably the same trick that they do with the double column.
It's not the same trick. Yeah, like this is like a reference. This is like checking a pointer essentially. But this, in order to actually guarantee that this structure makes sense, they have to call an unapply. Guess what? That reallocates the vector.
Yep.
What does that do on? Okay, we're on seek now. What does it do for seek? You don't know, depending on what the seek was. If it was an underlying vector, you're probably it's going to go to hell. If it was a list, it's still twice as slow as this. What does this do on array? If you try and pull off the head, it reallocates the whole tail. So if you have like a length 10,000 or a million array or whatever, and you want the head, and you're not using like dot head, and you're trying to just be clever because like, oh, I'm a functional programmer. When I get my array in, I'm just going to match on it, and I'll get the head, and I'll do something on the rest. No, you just reallocated the whole tail. Questions and comments?
How did you find out that?
I benchmarked it all.
So you said benchmark, I understand you said benchmarking, but did you get more details, like does the benchmarking gives you the finer options of how it was done?
No, that was mostly me finding horrible numbers and then looking at the code to see how it did it. Yeah. And those numbers and their implications and like general recommendations of what to use instead, kind of the stuff I'm telling you now, are all in there in much finer prose than I am producing on the fly. There's a section in this benchmarking thing that talks about chained sort of functional programming operations, if you wish, like maps and filters and folds and things like that. Scala does not fuse, typically. If you have stream, so fusion is when, okay, you
You have multiple maps and you turn a single map that composes the multiple
Yes.
functions for each map.
Yes. If you want to be mapping over a list and then you want to do, say, like a filter after you've mapped it, okay. When you map it first, it basically allocates the whole new list with everything transformed, and then it filters over that. And then say you call head on the end. Maybe you're being evil. You want to map and then filter and then find the head. Sometimes that's a useful use case. You would expect that it would map through and also kind of filter at the same time, testing for the predicate. And then as soon as it found, because head is there, as soon as it found the first thing that satisfied both like the map transformation and the filter, that it would just return it to you and it would stop allocating anything else. That's what Haskell does. That's not what Scala does. So Scala would allocate two arrays, like lists. You'd start with the first one, you map, you get a new one. You filter, you get a new one, and then you head. And then I guess it would GC the list that you didn't need anymore.
Although you could cheat by turning it into a stream and then doing map filter head.
Yes. So stream is okay.
Because that's the lazy, like Haskell.
Right. That is what I believed at one time. So I was really happy when I first discovered Stream, and I was using it because again, like I said, like I came to Scala from Haskell, so I was used to the like lazy list behavior. I saw Stream, great. This lets me fuse my operations, and I used that in a number of places. And I believe the numbers are there. I think there is a map filter head number in this repo, and I think it's decent for Stream. Iterator gets better. People get allergic to Iterator because it's mutable, but if you got a list in, or the list was local to the function that you're writing and it was never going to escape, and then you call dot to iterator, then do a bunch of things you would want, that gets you the fusion that you would have wanted. Then you can, it's actually, I believe it's faster, like if you want to do multiple chain things on a list, to go to iterator, map filter blah blah, to list again at the end. That's a little trick to kind of get around the fact that, you know, it would allocate intermediate lists the whole time. List, even if you don't do that, list is still decently fast for iterating. There's always going to be a difference between if you have classes in your list or if you have primitives. But typically, a list performs the same for either or because it doesn't specialize on, because it's generic, it boxes primitives, and so it doesn't, like it can't be faster for one or the other. I'll get to why that matters for array in a second. So list for just normal like dot map is actually pretty fast, and mostly the cost of, like, unless you've got millions and millions of elements, the cost of reallocating that stuff isn't all that bad. If you really want to be careful, do the dot or the to iterator trick that I mentioned. And then you will get that fusion effect that you wanted. So list is pretty quick. It's got the fastest desugaring of any other structure in Scala. And when you match on it, it won't do like evil things. What's an array? I'll move on because we're almost halfway through, actually. What's an array?
The non-shell allocated JVM from
Yes.
two holds things.
Yeah. An array in Scala, for all intents and purposes, is a Java array. You can basically think of that as such. There might be some wrapped array or some sort of array ops fusion method injection that it'll do, but for most intents and purposes, at least for performance, you can consider it to be a Java array. That's good because we got lots of languages on the JVM. We've got Scala, we've got Groovy, we've got Java, we've got Clojure, and there's probably other children around. But the core truth that we can't forget is that the JVM is for Java. The JVM is optimized for mutable variables and arrays and loops. We have to basically, if we want to be using a language like Scala, we just have to accept that and then try and work around it the best we can. So arrays can be good because they're a JVM primitive. If an array holds an int or a double, so here's an important point. If an array holds an int or a double, or probably like a short or some of the other few data types that there are, it's byte packed. It has a specialized representation to the JVM, which lets it iterate very quickly, like an order of magnitude faster than list is going to be. It'll let you do maps, or access is going to be random, of course, because it's optimized for that. It lets you do clones really quickly, and move stuff around. Like the JVM really likes arrays, is the conclusion. So it'll be the same thing for double. The array does not beat list or any other structure if it's holding classes. An array is not faster than anything else if it's holding classes. That's because it can't be byte packed anymore. It's now generic. It's holding probably just references to heap allocated ints. Or pardon me, not inst, like a heap allocated instance of your class, whatever it was. Why I mention you have to be careful is this. I suppose I didn't need to do that. There's like of dim, and there's also range. Like there's a number of ways that you can just inline define an array. Well, let's just pretend that we did one of those. Is this byte packed? Say you're in a method. Is this byte packed? Is this like the optimal?
Should be right.
Yes. Yes. Because you defined it in line like this. It would be a similar thing if you said it for double. Okay. Now we're writing a function definition. We will call it what every good programmer names their function when they can't think of a name. Foo. Hopefully this is visible to everybody. Am I writing large enough? Okay, good. Red is also visible to human eyes, so. If you passed in an array of int, and you were returning an array of double, is this byte packed?
I would assume yes.
Yeah, almost certainly it will be. Is this byte packed?
Is that an array of doubles?
Yes.
Yes.
Also no, right?
I'm pretty sure it is.
How do you byte pack the doubles though?
That's a
It's the assumption that you've done something like you've declared in here, like val d array double, as the result of maybe mapping over the int list, or you've now made a while loop, and like you've done sort of like essentially a for each, like for each index in the array that I was given, do a mutable update on this guy with and then you casted it to doubles or whatever.
When you say byte packet, is this I'm trying to remember. The JVM has a representation for that when you do a print on an array, which is a square bracket d, square bracket I.
Oh, that thing. Yes. If you see that, that means it's like the good, like optimized representation in the bytecode of the array. I'm motivating for something. So this will still be the good representation that the JVM knows how to iterate over very fast. This will still be like an order of magnitude faster than trying to do the equivalent thing with list. We'll get to why. Yeah? Was there a, okay. for both of that, and it can do the fast clones. It can when it's GCing, it can move this stuff around very very efficiently. Okay, time for the big leagues. That's annoying. We'll erase that. Let's introduce a B2. If I pass an array of ints to this, will it be byte packed?
Can't possibly be,
Why?
because this is compiled to array of objects, right?
Yes.
Wait, hold on. I'm pretty sure that compiles down into the type of A is object, not array of object.
No, it compiles down
Let me
to
double
array
check.
of objects because there is the only array that actually exists. That's not a primitive.
Right, but if I
There
have
are no generics.
no, I know, but if I have an array of int and I pass it into this function, Scala's not going to reallocate my array as an array of boxed integers.
Won't it?
Okay, I'm checking right now.
So we're debating about this. Will this be byte packed?
I would give the same answer.
I'd like to say it depends on whether or not B is a primitive, but I bet that's not the right answer.
Unfortunately, that's not the right answer. This will. So whether or not this is byte packed or not, this will certainly not be. It will be upcast to object and allocated on the heap. You've just destroyed your performance and any gain you had by using arrays. That's why array, when it's an array of like the special things, that's why it's an order of magnitude faster than list. List is properly generic. If you have a list of ints, those are actually boxed, allocated on the heap, so it can't do like cool things to it. Basically, when that happens, this becomes no better than list. It becomes list with random access. Yeah.
What if you specialize on B? You specialize B to ints and other things you might want to do column.
Did it?
It erases it to object, not to it erases it to object, not to
Not to an array of objects?
not to array of object.
Does that imply that everything in is object too?
No, because if you pass it an array of int, it upcasts the array of int to object, which it can do, and it passes that in. And then in Scala runtime, object, which is part of the library, there are generic operations for operating on arrays that type case on is it an array of int, an array of boolean, an array of whatever, an array of some reference type. And they just have a huge type switch inside the method
Okay.
to pick the right JVM opcode.
Okay. If that's the case, or I believe that's the case, I do have numbers that show that it still boxes if the
Taking
result
stuff
is,
out.
yeah.
Yeah, your host taking stuff out. Putting stuff in, it's not nearly as bad as you think, I don't think.
Okay.
It's
So
not
you can see that it's like we still are having a debate about this. The point is that really, regardless of what the actual behavior is, the point is that if you want to be generic over arrays, you're almost certainly not going to get the effect that you wished. So why would you want to use array? Array, if you're using classes in your array thinking that you're going to be fast, you're not going to go any faster than list. If you know you need random access, great, then use array, because that's what it's good for. But don't have any misconceptions about, I'm going to be doing my maps or my while loops are going to be super fast because it's an array. You're no better than list. If you have to do something that does not require random access, you might as well use list. Again, because of all the reasons of it can desugar very, very quickly, you can recurse over it very quickly, you can cheat to get fusion, but if you don't want to bother, it's fast enough. If you absolutely need random access, array is good. With that in mind, what is vector 4?
To be the best functional collection on all fronts. That's the advertisement
Be what?
in the box.
The fastest, like, the catch-all fastest functional.
Yeah, its function
Collection.
is immutable, it has fast random access, it has fast head and tail, fast concatenation, fast last.
Just wonder about how it doesn't have fast tail
Supposed.
out.
It's supposed.
Okay.
It has fast last.
I'll keep that in mind.
So, why I have vector on this list is because what algorithm? So, pardon me. Before that, Pedro did point out something to me at lunch, which was important that I do need to actually go back and add to the benchmarks. Is that vector is going to be good if you need to concatenate two large vectors. I'm going to find out how large they have to be to make that worth it. Why is list plus plus another list bad-ish?
Because you have to walk completely through one of the lists, one by one.
That's true. Why is array plus plus array kind of bad-ish?
You've got to make a new array and then put both sides in.
Allocation. So, okay, if we can cheat and do something cool with, like, if there was a fast way to do that, then great. And that's basically what vector can do. Okay, so you've got these two giant vectors. I don't know how you got them because it's actually not that cheap to construct vectors. I can.
Well, we paid the price.
So I have questions about how you even got those. What algorithm are you writing such that list is not what you need, but you also need random access, but for some reason array isn't good enough? What hole does vector fill there? Is my existential question. Yeah,
Well, not regarding that, but I did have a question.
sure.
We use vector a lot, and I think it's mainly because of the concatenation.
Okay.
A lot of bytes are going through at that time, but I did want to ask something about the Scala benchmarks. I looked at it right now.
Yeah.
How come sum and full left were different numbers in your benchmarks?
Yeah, because sum isn't implemented in terms of fold left. Sum has like an implicit like numeric thinger on it, which puts overhead for some reason. Actually, sum is also bad in Haskell if you're curious. Never use sum in Haskell. Always fold left.
Oh, it's like when because of the implicit numeric.
Yeah, somehow that screws it up.
Gotcha. Thanks.
Yeah. Okay. So my question for you is, where do your vectors come from? How did they get to be vectors?
They are constructed.
Hmm?
They are constructed like the other collections.
Like, did you build them from nothing? Did you use vector builder? Was it like a cast from an array?
Hopefully vector builder.
I would have to look into it more because I've only dealt with getting past it.
Okay.
But my assumption is they're probably just reading the bytes off some Akka stream and just putting it into the vector.
Which can be really bad if you're doing that whole like you had the vector and you were just using like that cons operator to just put on, because it reallocates the whole vector every time you do that.
I don't think they were doing that.
Okay, good.
I think it's immutable. Mutable, sorry. So I think they're not like depending cons per se.
Okay.
Functional.
So my plea to you is find out how they're doing that, and then if they're not using vector builder, use vector builder, and it's in there. For building collections out of nothing, where it's like, okay, for some reason you weren't able to use FoldWrite or whatever, what collections are quick to build up from nothing, vector builder pretty much wins. Array builder is pointless. And again, that's all here.
Right.
So cool, yeah, if you have to do that, if you have to be doing that concatenation and that's your prime use case, then I'm sold that vector is actually useful for something. We might only be able to talk about collections, which is actually good enough for me because I can talk a lot. Seek. What's a seek? Or pardon me, is there any more questions about vector before we move on?
So you'd only use vector if you have a large data set and we need to concatenate.
Yeah, and it's like, why do you even need to do that?
Yeah, I mean, this only if you are working with large stream of data
And also, we don't know how large. I haven't benchmarked it yet, but it's like, do you have 1,000,000 things? Is it like 1,000 things? Like, when does the fast plus plus of vector matter versus list?
and that's what I was going to ask, like when you
Probably
decide
it's not going to take that
for it to be worth it?
Yeah, because this is quadrat. I don't know, it's just linear, it's not quadrat.
Mm.
Never mind.
And like, who knows what the allocation cost of the array is? Because like, it probably could be quickish once it does the allocation and then just blasts through the two arrays. That might be quick. Cool for vector? Sweet. Let's talk about seek. What's a seek?
I think it's essentially an interface.
Which in Scala we call? A trait.
Yeah.
Yeah. So seek is not a concrete container. Despite that, you can do this.
What does this do?
You can go seek blah, or you can go like seek, like 1, 2, 3, happily along, as if it were a concrete container.
Because there are applying methods that convert it into the underlying data structure.
Right. They decided to make like an OO hierarchy about this, not like a functional one. You don't know what seek's going to be. Seek will typically default to list, but as we showed, you don't get the benefit of list, in particular like the desugaring.
It doesn't return this, it returns seek.
Yes, exactly. It's shadowed as seek on the top level. I mentioned like that giant graph of like capabilities that everything, like if you go to the standard library and you look at list, it'll be like, oh, list extends, list like extends, gen list, blah blah blah, and you can there might be visualization tools, but eventually you get like these like extends blah with 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 blah.
It's a great picture if you Google for what part of list don't you understand, you get the whole
Yeah, it says
hierarchy of that.
right here.
Oh, here we go.
Posted in the Lambda Conf channel, but
Okay, cool.
it's the diagram.
Cool, that's very useful.
Diagram of the
It's a diagram of the superclasses of list.
Okay.
So the result of all of our actual base, like useful containers inheriting the entire universe, the result of that is that almost all of them have a ton of operators that are similarly named, have similar return types, but depending on what they actually are and like depending on the implementation and where that implementation like actually came from in what superclass, because it can be different depending on what the actual base thing is. Like, for example, append is one of such methods. You can look at it and it looks completely harmless. Oh, I give it an A and it returns like, the collection with the A on the front of it. But as we saw before, depending on what it was, that might suck.
That's prepend.
One of those prepender, yeah. One of those for list builder in particular, it's like, I can't remember exactly which one it was, but there was a horrible difference between doing like this or that. And like one is like quadratically slower than the other, but you would never know from what the methods are. So the idea, like, we have this huge inheritance, this huge like graph of things that we're getting capabilities from, but there's no sort of advertisement, and often the doc strings are generic because they came from the superclasses, so you have no idea what the performance capability is, what the actual behavior is of it. If you had a method that took in a seek, and why this is relevant is because if you had def foo, and it took in a seek of whatever, and it returned whatever, what is that? You have no idea. So then how are you supposed to do anything with reasonable performance guarantees in your actual algorithm? You want to be like desugaring it, you want to be mapping over it, you want to be like appending to it and like returning some stuff, you want to be splitting it in half, you want to be concatenating two of them. But if you have no idea what they're actually going to do, you can make no guarantees about the behavior of your program. So I will recommend to avoid the OO way of approaching this and just be honest with yourself and your coworkers and your application and be explicit and use list. Or if you know that you're dealing with primitives, use arrays. Or as was mentioned, if you know that you're concatenating large pieces of data that were constructed in good faith, use vector. Avoid seek. Do not write APIs in terms of seek. I've written my share of code that just did with seek that like deconstructed it and all these unapply calls would happen. Like I'm not claiming that I'm like the angel here. I've written plenty of this crap. Any more questions about seek? What's a stream?
Supposedly, a list
Lazily
with a list head and a list tail, but that's not I know this is not true.
You would like it to have a lazy head and a lazy tail. Unfortunately, Scala's stream, yeah,
It's lazy
it
in
has
its
a
tail,
stripped
not
head.
its head. 213 has lazy list, which is lazy in its head and its tail.
Okay, and I believe Scala Z ephemeral list is also lazy in the head.
Yeah, we have a female stream, and that is
Or, yeah, pardon me.
that is lazy in both places, but it's also not very good for other reasons.
It's not fast, no. The idea is that, yeah, it's like, okay, maybe it's okay if the thing in your stream was some large chunk of work and you knew that you would want to be skipping parts of it if you had hit some sort of specific, specific condition, a la the map filter head example I gave before. What if that map is like really, really expensive? Who knows what domain we're in? And the filter could also be expensive. But it's reasonable that the thing you were actually looking for with your head was like the third element in. Okay, so you've paid a heavy price to process the first one, but that wasn't it, it got filtered away, fine. The second one, okay, fine. But you hit the third one, there were like a million more elements that would have been really expensive to do. With list, you would have been screwed because it would have done all of them it would have done those expensive operations for all of them. But with stream, at least, you would have sort of ducked out early. It's the same thing for iterator. Unfortunately, if that's not what you're trying to do, like if you know that you're not trying to skip unneeded work, stream is quite a bit slower than the other collections for basic usage, mapping, filtering. If you go to a Scala REPL right now and you type in stream.fromRange 0 to 10,000 and try to fold right over it and try to sum everything, it will blow the stack. Fold right on vanilla stream blows the stack, so please do not do that. Please do not use stream, basically. And again, the same thing with vector. It's like, okay, prove to me that you couldn't have written an algorithm that was good enough with list, or where array or list wasn't good enough. I'm not going to talk about map values. Don't ever call that. It doesn't do what you think it does. It looks seductive, but don't call it.
Trust me, don't call it.
Yeah, don't do it. As of Scala Z 7.2.23 maybe, and CATS 1.1 or something, the functor instance for map has fmap, because Scala already took map, but even so, both Scala Z and CATS supplied like map as the injected function for doing like functory things. But what if your thing, the map, the .map method on map doesn't do the usual functory thing. It gives you the key as well, which is sort of assumption breaking. And what happens is that if you wanted like the functor map, which only gives you the value, it actually won't inject. If you call map.map, map.map, with the way overloads work, it won't let you overload with the one you wanted because the signature was fundamentally different. So to get around that, there is now an fmap, which is like sort of the Haskell style, which will only give you the thing that you wanted, the actual value. So the collections hierarchy is large. There are a lot of operations in there. You don't need most of them, unfortunately. Things can be confusing. Seek will confuse you and your coworkers and your users. Stream is probably unnecessary depending on your algorithm. Vector is probably unnecessary depending on your algorithm. If you need random access, use an array. If you're just doing if you're just holding stuff in a list and you don't need random access and you just want to be doing some mapping and filtering or destructuring your container, use list. We talked about the trick for getting fusion back. There is also ilist from Scala Z, which is actually even faster than list for destructuring. So if you really want to be doing like the fastest possible tail recursive algorithms over lists, that also exists. We have 12 minutes. What would you like me to talk about?
Do any val.
Any val? Okay. Do people care about any val?
Sure.
Okay. Have you heard of Scala 3's opaque types? typically referred to as new types, or otherwise referred to as new types. The idea is that, and because we had that boxing problem before, if you wanted to, like depending on your application, if you have just ints and doubles flying around, those aren't very semantically useful. Like if you got a function that like takes 3 ints and produces something, it would be very easy and forgivable. Like it would be an understandable mistake if like you or your coworker mixed up one of the arguments and that totally blew up the behavior of your program because you passed like, age of the user versus like the money that they should have in their wallet, and you just totally like ruined their bank account or something. I wouldn't want to do that. So what you can do is kind of new type a
Erasable wrapper.
So it's like, okay, one thing that you could do is like, oh, okay, I'll just like wrap it in a class that had only that. And that way now there's this thing called money. And sure, you have to worry about like, manually wrapping and stuff, because I will come to your house if you use implicit conversions. There's a little bit of overhead involved, but accept that, because when you're actually calling it, it means that you can't call your function with arguments in the wrong order. You've like semantically given this meaning. Unfortunately, as we saw with like the array stuff, what happens when you do this?
It ends up becoming a reference instead of a value.
Yeah, this might have been like cool and efficient and everything, but this has to get allocated on the heap. Not so, says Scala. If you extend any val on a case class that has only one thing in it, it doesn't always work. And there are a lot of caveats, and you can look up like on Google, there are blog posts and things about when any val doesn't properly work, but that's the current solution in Scala 2 for how to do new types. What will happen is that if you've satisfied the conditions for where that works, and I can't remember exactly the conditions where it was and where it doesn't, then Scala will essentially strip away the money wrapper, and it will operate as if the int was there. And so you get no punishment for having to allocate there. But it'll still type check as if the wrapper was there, which is really handy for program semantics.
Is that also true if the value is a string?
Yes.
Why?
I think it works better for any refs.
Isn't a string a reference?
It's in a lot of ways better for any maps, because if you have an int in a generic context, you need to box it anyways if you're going to do anything with it other than operate on it as an int. Whereas if you do this with any val, you have to box. If you do this with an any val and you don't use the wrapper class, you have to box. And if you do use the wrapper class, you have to box. But because Scala wants to be able to pattern match on a generic variable that may contain an anyref subtype and still somehow get back the fact that it was wrapped, then if you have a string, you have the string on the heap already, and then you additionally have to box the string. So for anyrefs, it's different like that.
Yeah, it will be more eager to unbox the or to erase this wrapping for things that are any refs, which is like when you use things. One of the conditions where this will fail is if you use something that extended any val in a generic container. That will ruin the. I believe what I just said was true. That will ruin the Scala's ability to erase the wrapping. But luckily, if you're patient enough to wait for Scala 3 has proper opaque types, which will give the new keyword opaque. I don't need to tell you that. Opaque type money equals int, I think is the syntax. And then they will type check as if there was a wrapper. You won't be able to go like, if you had something that was labeled as money, you won't be able to add it to another int because money's not an int as far as it's concerned. But once you actually compile, it'll disappear and it'll do the fast thing against 2 ints, which is what you expected. This might help us with like the array stuff. Like we might be able to get around the whole like boxing of primitives in arrays if it was generic. We'll see, which could be good news for numerics in Scala. Right. 5 minutes. Or no, are we done? Does it have to end early so that people can move? Probably, eh?
One quick question.
Sure.
Since you have a repo there that says Scala Z cats.
Yeah.
Scala Z or cats?
They have the same API and the same performance, essentially. There are Scala Z has a little bit more, a little bit bigger of an API, like a little bit, like I'd say it's more featureful in general. Scala Z sticks to Haskell terminology a little bit more. In terms, also with like operators that are included. They both have a ton of resources for learning. There are both very smart, hardworking people behind both projects. It's unfortunate that they have to be split, and there's a lot of, like basically wasted effort of people implementing the same things. I think that's rather unfortunate. But in general, and they both have like increasing library ecosystems. Like there are all sorts of libraries that will use one or the other and let you do things that prior to like 2 years ago just weren't possible in Scala. Like we were stuck just writing vanilla crap. Now you can actually be doing sort of like pure functional parsing, JSON handling, recursion schemes, database access, HTTP4S. If you see Chris Davenport here, he's like one of the maintainers of HTTP4S. That's like a revolution in writing web servers for Scala. And it uses like I/O, and Doobie does as well. Doobie is the database library for that, and it basically tries to get away from futures. It tries to get away from impure functions. And overall be a lot less verbose as something like Akka HTTP or something would be.
And I assume that they have diverged enough that there's zero chance of them ever getting back together, that coupled with the early animosity.
Let's see. There's also a library called Shims, which will let you use, like if there's a library that's a cats library, like it was written with the assumption that you'd use it with cats, you can actually use it for free with Scala Z if you just import. You depend on the Shims library, you import shims._, and then this structure that was expecting like a cats instance of, say, applicative or functor, if given a Scala Z instance of functor or applicative, it'll just work. So in terms of interop, there's essentially no difference. In terms of getting back together, I mean, like...
You said they're both really good, they're upright people on both sides, and too bad it's two totally different things.
It's unfortunate that there is like repeated work. Do they need to get back together? Maybe, maybe not. Like they kind of like innovation in one kind of spurs innovation in the other. So in that sense, it's good.
It's good.
In that sense, it's good. I take a step back and I say, all of this crap should have been in Scala to begin with.
Yes.
So shame on.
A little bit of a leak
Oh,
into Scala 3.
there are long discussions on the mailing list saying, oh, we should have like this, like that. And Martin and other people saying, no.
Thank you very much.
Yeah, you're welcome. Thank you very much. Hopefully this was useful. So please, even if you forgot everything that I said today, if you take that link and that link back to work and show people and say, particularly there's also stuff about how future is garbage. Like if you're writing very future heavy code, it's most likely running way slower than it has to be. And if you're using like, if you're doing naughty patterns on certain collections, you could be running things 100 to 1,000 times as slower than you could be. So, thank you very much.
Thank you.
Thank you.
Thank you.
Thank you, everyone.